All right, let's look at number 33. It looks, you look at this and you say, okay, there's no GCF that can factor out, but maybe there's something else I can do. So if you remember what we can do, you can try, guess, and check. Another method, though, that I've suggested to you is that you take and you say, I'm going to multiply the coefficient of the first term times the constant, which is 4 times 6 is 24. Remember, this is what we have to do if we have a number in front of our square term, like we do here. Okay, so I'm trying to find two numbers that multiply to give me 24 and add to give me the number in the middle. We've always kind of added to get the number in the middle, but sometimes we have to do this little extra thing here. What's a negative 9, okay? All right, so if you try to think about things that multiply to give you 24 and add to give negative 9, you got 1 times 24, no way you're going to get 9 out of that. 2 and 12, 12 minus 2 is 10, so they have a difference of 10, not going to be 9, that's not going to help me. 3 and 8 add to 11 and have a difference of 5, so there's no way to get 9 out of that. 4 and 6 add to 10, and they have a difference of 2, no way to get anything out of there. And I think we've got all the factors here. Let's see. Yep. Now, we can't find anything that works here, and you can search as long as you'd like, but this ends up being prime. It won't factor, so there's no way to break this down. If I wanted to solve this and find the solutions, find the solutions to it, which remember those would be my x-intercepts, I can't factor to do it. So maybe what I do is I go do the quadratic formula because it would always work and tell me what my solutions are. But here, we're just asking us to factor it, and it's prime. The next one we're going to look at, is x to the 4th minus 3x squared minus 4. Now, I don't know if you remember us talking about this before, but when I see that I have an x to the 4th and an x squared here, I can kind of look at this. I can try to factor it like I would normally factor, and I can say instead of putting an x here and an x in the first slot in both parentheses, I can put an x squared here and an x squared here. And I can now try to factor it just like I would as if this, I can treat this problem as if it were x squared minus 3x minus 4. Because when I multiply out, these x squareds are going to give me that x squared in the middle term. So what I'm looking at is I'm saying, okay, I'm trying to find something that multiplies to give me, okay, if you look out in front of my square term here, which is really x squared squared, x to the 4th would be my square term because I think of it as x squared squared. There's just a 1 out in front of it. So I only need to say, oh, I'm trying just to multiply to get the number on the end, negative 4, and I'm trying to add to get the number in the middle, negative 3. Let me put add here, let me put multiply here just so we are clear on that, okay? All right. So I know that 4 and 1 have a difference of 3. Now I want a negative 3, I would need to make mine 4 negative, because negative 4 plus 1 would be negative 3, and of course negative 4 times 1 is negative 4. So this would factor into x squared minus 4, x squared plus 1. Now, we got to keep checking because we've got x squareds in our parentheses. It might be that we could keep factoring this, and we can here. If I look here, I've got x squared minus 4. Well, that's a difference of 2 squares. If you remember, that would be x and x here to get the x and x would give me the x squared in the first term. There's two terms, there's a subtraction sign, and I got a square. 4 is 2 squared, so I could put a 2 here and a 2 here. So one of them needs to be a plus and one of them needs to be a minus. Now I've still got this other factor here, and since it's got a plus sign here, it won't factor. Remember, when you have two terms with a plus sign, they do not factor, at least not into real numbers. So we're going to just put x squared plus 1 here. And we're done, because since that won't break down anymore, I'm completely finished factoring at that point. Okay, the instructions on 45 tell us to find the GCF and the LCM of the given polynomials, greatest common factor and the least common multiple. All right, so you kind of got to think back to what you learned about these things back in elementary school, and I know that we at least did these things up through 7th grade. We still were practicing them, but you might have forgotten a little bit about them. Now, if what I have to do in both of these cases, if I want my greatest common factor, that's the biggest thing that divides into both of them, okay? So I'm looking for the things in common. The C stands for common. What do they have in common? Okay, so we'll do that first. In order to do either one of these things, though, I have to factor these two expressions up here, okay? So if I look at this, I'm thinking on the first one. What multiplies to give me 2 and adds to give me negative 3? Well, that one does factor. negative 1 times negative 2 is a positive 2, and negative 1 plus negative 2 is a negative 3. Okay, now this is really what we want to do when we want to factor. We want to try not to have to always draw that little diagram to have to do it. So I'm going to try that now from now on. All right, on this other one, if it factors, I'm thinking what multiplies to give me a positive 4 but adds to give me a negative 4? Well, that would be x minus 2 and x minus 2. Negative 2 times negative 2 is a positive 4, and negative 2 plus negative 2 is a negative 4. Now, for the greatest common factor, we're saying, okay, what do they have in common? Okay, so let's look at each one of these factors. I have an x minus 1 here, but it's just in the first expression, not in the second one, right? So let's look at, I'll circle this one. There's an x minus 2 here. Oh, look, there's an x minus 2 here also. This one actually has 2 of these x minus 2's, but for the greatest common factor, I want each factor the least amount of time that it occurs is the way to look at it, okay? So what do they have in common? They have 1x minus 2 in common. So the greatest common factor is x minus 2. That's all they have in common, okay? Now the least common multiple, what you need to do that is you need each factor the most time it occurs in both expressions, okay? Because I need something that both of these are going to divide into. I want a multiple of them, and both of these terms need to divide into that term. So how I do that is I go, okay, let's look at each thing. I've got an x minus 1, so it's only up there once. I'm going to list it once. The next factor I see up here is an x minus 2. It occurs once here, but look down here. It's down here twice. So in my least common multiple, it's going to show up twice. I need each factor the most amount of time it occurs in either expression, and I need to have each factor represented in my least common multiple. Okay, and that's it.